Hello, everyone. Welcome to another Bounty episode of the Day Zero podcast. I'm Spectre, with me is Z. Today we have a pretty crazy Android crypto issue, some Docker container escapes, and more. So we'll start off with the Android crypto issue. So this was a post that was made by Meta's Red Team X, and it's a post on a pretty simple issue affecting various Android devices via the Apex module updating system, or Android Pony Express, which was introduced in Android 10 as an alternative means of updating system components without having to install full OTA update images. And it also allows updating of components that aren't in the standard Android application model, like hardware abstraction layers or HALs, class libraries, things like that. And of course,
Basically, it's a
where
lot
these
of
are
very, privileged and sensitive content that you can go ahead and update with these.
Yeah. So, of course, where these are update files and there are sensitive components, they're supposed to be signed. That way, attackers can't just install arbitrary malicious update files to compromise the system. The problem is that some vendors ended up using private keys, in quotes, that were the test keys from the AOSP public repository. Oops. So, not so private keys. The Apex that they call out is particularly powerful here is the com.android.vndk, which includes the hardware abstraction layers that gets loaded transitively into a lot of system processes, including the Zygote loader, which is like the most privileged process, pretty much. And actually, Meta doesn't put the blame on the vendors here. So although this only does affect certain vendors, they mostly blame the Android project's poor documentation and unsafe defaults here, as well as the compatibility test suite's inability to check several Apexes, including the VNDK one I mentioned, especially because so many vendors made the same mistake. So these vendors include Asus, Vivo, Nokia, Microsoft, Lenovo, Fairphone. So yeah, they go into a little bit more detail saying that the compatibility test suite, or CTS, will try to check like APKs and Apexes for insecure signatures, but they hard code the list of test keys, which, over time that just kind of gets forgotten about, it outdated, and it missed several Apexes. And they state that this divergence is basically inevitable because, unlike APKs, Apexes have all different test keys. They also call out unsafe defaults, as there is a script, assign target files APKs, which resigns a build, and it doesn't replace test signatures. And furthermore, Android's documentation pages don't even mention Apex signatures in their sign builds for release page, and the test keys are not made clear that they are test keys. They're just called like apexname.pem. There's nothing indicating it's a test key in there. So unless you were intimately familiar with the system and had a clear intention of going through the build system and changing these keys, it would be very, very easy to miss. So yeah, in September of last year, they reported this to Google, and a week later, there was a security advisory issued for vendors, and they also contacted each vendor individually, and they added a test to their build suite test for vulnerable Apex files. So the way that Google responded to this was pretty good and everything. They contacted everyone, made sure everyone was aware, but it sort of speaks to a bigger issue within Android, and that's just that, like, in a lot of cases, the documentation is very lacking, and it's very difficult to build Android even normally, never mind like securely as a vendor. So as much as it might be easy to go like, haha, these vendors use public private keys, uh like there's a lot of circumstances that made this, as they say, inevitable to happen. It's very hard to do securely because of how it's structured.
Yeah, and I should also call out that Google offered a $7,000 bounty for this report. And I want to jump back on when you're talking about the insecure defaults of that script. So the normal flow would be that you do the build and it uses these test keys. Using the test keys is kind of expected. That's what the whole build system does by default. That way, even when they require the signing, require things to be signed, even if somebody doesn't have like their own keys, like if you're a developer just doing a really quick build, testing something, whatever, like it builds it securely in the sense of it is using keys at least. Just not the production keys that you then use this file to replace your keys. And the idea being that you would provide a key map. This key, when it comes across this test key, the script is supposed to replace it with this other key. So if you don't provide it that mapping, then by default, so if you give it no argument, it doesn't replace any of the test signatures. It will replace the test signatures. And that's what I want to call, because Spectre mentioned that just doesn't replace the test signatures by default, but It will if you provided the appropriate arguments, but it then means knowing every single key that needs to be replaced, and there's no warning that, hey, you didn't replace things, and kind of some aspects of that, which I think would be more important. Because the behavior itself, I think, can be kind of explicable here if you don't have keys to replace with whatever. I think like maybe a warning should be issued on that, when keys are left unchanged. Even if it doesn't know that it is the default here, something just being aware like these keys were unchanged and you can check that output to be like, is that expected? That would at least be one kind of option on that rather than just doing it silently and being like, oh yeah, it ran fine, we're good. And it actually not having done anything. There are different UIs you could probably use there, but like it is somewhat explicable that it doesn't do that. It's just that I think it should do a little bit more to inform the user that it didn't in fact replace a lot of keys or, didn't replace all the keys that came across or something like that. All the keys may
There's
not be
sort of a
practical because
perfect
there will be because there will be things that they don't replace the keys on, but sorry, what were you saying?
well, I was just saying there's sort of a perfect storm of issues that attack the vendors here. uh,
Yeah, it's a number of
Multiple
things
things
like
failed.
uh, and the documentation thing, like that is a classic issue. Documentation always goes out of date. Relying on documentation, it's very rare that a development team puts priority on keeping documentation up to date. And the other half of that is when one documentation references something else, it's really hard to know about that reference. And so you get these out of date references where one area talks about, like they call out here, where one area mentions that the only things using keys are the APKs and was it kernel modules? No, it was APKs and something else, but it didn't include the apexes. That's kind of what matters here. But just didn't know that apexes were added as a sign thing, and that was just in one area of the documentation. Somewhere else, of course, it does reference it, and there's no way to really cross-reference documentation for a developer who even wants to do that to find it. So
I mean,
documentation is just hard.
I will say in general though, like Android's documentation in particular has always been pretty bad. I think because kind of like you said, documentation does tend to go out of date in all cases, but because Android is so fast moving, within like a few years, information that was documented can be completely deprecated. And even like the more popular documentation pages, like let's say just building Android in general, even the build Android page almost every time I've gone to it has had incorrect information and I've had to figure it out myself, which really sucks. It's very frustrating. But as you say, like documentation isn't a particularly fun job. It's not something that people are jumping to do. But especially with Android, like where it's so commonly used, widely deployed, I wish the documentation was maintained better. And this issue kind of speaks to that. Like it's not a direct consequence of poor documentation, but it definitely plays a big part in it. So,
Yeah, the other thing that would be just kind of a code smell, actually, in this case, is when they do talk about the test coverage and how they use those hard coded list test keys. Like, as soon as I read that, that's going to go out of date because somebody, maybe changes or adds key or whatever, doesn't know about all of the tests and hasn't read all of the tests to know that needs to be updated. They need some sort of way to resolve what the test keys are. And then that comes into another thing where the APK keys are like centrally located in one folder or whatever, and the other keys they need are like central locations, whereas the Apex keys are more spread out and hard to find. It's kind of the challenge there with even writing the test to do this in like a generic way, but the fact that it did have the hard code thing just kind of screams to me that there's going to be problems because that isn't something you can figure out in code when that needs to be changed. So somebody's going to forget it. And that just comes down to a design aspect of how they're detecting it and stuff. So I guess I just call it like writing the tests is good. Having test cases is good, but whenever you hard code things into those test cases, especially when it's external things like the keys, you need some way for people to know that key changes require updating the test, which just makes it impractical in my mind. It's just, you can't really do that anymore, or it's just not a good solution in my mind.
I kind of wonder why these Apex modules all have different keys being like used to sign them, because they mentioned here that APKs generally have like one key, so it's a little bit easier to manage, whereas with the Apex modules they all have different keys. I'm not sure
Diverse
why.
sources, diverse modifications. That was my guess. I don't know why either. But my guess was just more for
I agree.
diversity, whereas the APKs, kind of have either that high level signing where it's like one key signing many things.
They're more
Um,
centralized, yeah.
yeah, or having more of like the chain, even like having the chain of signatures saying, this thing signs this key to do this sort of deal. Whereas I think with the Apex modules, it probably doesn't have that sort of setup, and just a lot of different places these keys or things, a lot of different places could be providing these signed Apex modules. It's not just going to be like the one builder or something.
You do have a lot
Uh,
of vendors in the Android ecosystem, so that's yeah, you're probably right. There's a lot of like stages in the pipeline, as it were. And when you're talking about hardware abstraction layers, you have a lot of chip vendors and things like that are going to ship code.
yeah, like I don't know if that's what played into the choice, but from the outside, it does in fact sound a little bit weird that that is the case. But there is probably a business reason for it. I just don't know it, so I have a guess.
Yeah. I mean, another takeaway from this whole ordeal is that crypto is hard. Hard enough that even in a project that's as globally popular as Android is struggling with it.
So
So,
there is something to be said, perhaps, about the fact that Android does do the builds with signing everything, because this would be a lot easier to detect unsigned. If it was just an unsigned Apex, that would be a lot easier to detect than they didn't replace the signature. That said, as a random developer, they may want to be able to do that signing. So, like, I kind of appreciate the fact they do the signing in the build, but this is a place where that kind of also seems to be the mistake, because it's really easy to detect a unsigned thing. It's a lot harder to figure out if it's not the right key used to sign it.
yeah, I mean, I think this is something that suggests that a build and then sign or finalize stage is a better way to go than trying to do it all at once. But
Well, yeah, okay. I was going to say, like, they do have the finalized thing by changing by this like key swapping, like sign target file APKs, where it does the re-signing the build. That is kind of a finalizing stage where you just give it all of your key mappings and let it go.
yeah,
But
like I
yeah.
said, fairly straightforward issue, like literally just private keys being disclosed and used in production. But it's complicated of how it happened, and it's with all the nuances explained, it's really not a surprise that it did happen, and it's hard to blame the vendors on this one.
Yeah, it's a hard thing to solve. I, I don't put a lot of blame on the vendors. The same time, even on Google's side with documentation and stuff, it's just hard. Obviously, blame I think can go there, but there are challenges with keeping documentation up to date. That because Google has a lot of documentation, it's hard.
They try, but yeah, it's difficult to keep it up to date. Like I said, like Android is just really fast moving, right?
Yeah,
It's easy for information to become outdated quickly. All right, so getting into our next topic, we have a post from Secure Next on mod security, and I'll let Z get into this one.
yeah, and this one's a pretty fun issue. It is a path confusion, fairly trivial bypass for a lot of checks on version 2 and version 3. Version 2, I don't believe has been patched, but version 3, which is still maintained and actively worked on, has been patched this issue. The issue comes down to how this request line gets parsed, and how, well, I guess more specifically, the various variables that when you're using mod security you get access to. So it'll give you all these variables that you can then access and do your check on. Does this contain something looking like a SQL injection in here? Is this a file name we don't want to let people request? Does it have an extension that we don't want? Whatever. And so you'll have arguments provided. You can access the args variable. You could also access, and the main one here, or at least the main one this post talks about, although this does impact some other variables also, is this request file name variable. And what you would expect usually, there's an image up on screen here that shows a standard request line, get slash API, whatever, and then they have some query parameters, and the request file name should parse through here and, run into this question mark showing the start of the parameters and kind of end there. Won't include the question mark. It'll just, there's the path that they're requesting. So you can do all your checks like file extension and whatever there. Or just, are they trying to access a path you don't want? Whatever. Or you can do basically whatever sort of check you want on that. The problem is that this request file name, so there are different kind of parsing stages that you can have your rules run. And request file name is going to be generated after the request line here has been URL decoded. So what that means is that if you were to have a URL that contained the %3f in it, which is the URL encoding of a question mark, if you had that in the URL itself, then when this goes to fill in the request file name, it is going to parse until it comes across. They've got the example here again up on screen where you have the %3f in the middle of the request. That is going to get URL decoded. You're going to have a question mark in there. And then when this thing tries to get the request file name, it is going to parse not until the actual question mark that's before the argument. It's going to parse until that first one where it's the URL decoded question mark. So it's going to basically stop there. And that's where the request file name will end. So because of that, anything that's trying to check just the path, even though like by default, the server handling everything is still going to read like the entirety of this until the question mark. Like what I'm highlighting would be the actual path, and it includes like the SQL injection in there in this example. By including that %3f, it basically just stops early and you end up not including part of the path. You don't get the full path in there, so it's not all being validated. And just like that, you're able to basically have this little piece of data that's in there and part of the request file name that isn't actually validated, or isn't actually checked by anything that's just checking the request file name. And because of that, you can slip through, and they have an example here of just a simple PHP application that uses the ID out of the URL to execute a query. And then basically by hiding a %3f in there, they're able to get this whole SQL injection just to not be checked and included in the request. So it really is that simple. Including %3f and anything after that as part of the path won't get checked by any sort of security thing using the request file name. So that includes like your core rule set, like the OAuth's rules. And they also talk about other file names impacted by this, include the request file name, request base name, and path info. So several things kind of have this issue. They are checked by like common rule sets. So that's the CRS. So it gives you pretty trivial bypass. They also talk about kind of a fun one when it comes to accessing file names, where you could just game because of the ordering of when these things happen for the file names and for checking extensions on that. What would end up happening is basically if you just URL encoded the dot character, it wouldn't match any extension because that one ran before it got URL decoded. Which meant that it would still get parsed out, but or like on the server, it would end up in the right place, but the rule wouldn't run at the right time, giving another really easy bypass on another type of rule. Of course, the rules will vary. I mean, every WAF, a lot of WAFs will at least start with the common rule set, but not all of them are going to only use that. Many will have some extras in there too, so it's going to depend on the actual rules, but anything that's reading and trying to validate the request file name prior to this being fixed legitimately had no way to get the entire file name, because the earlier version I believe would end up returning you you can get basically the entire like request line, but if you want just the request like file name in this case or path or whatever, that all happened too late, so you couldn't get anything after that. And that was actually opened as an issue. I'm just trying to find where they have the link in here.
The 2022 CVE, is that what you're looking for?
Not a CVE, actually, but yeah, ModSecurity GitHub repository on March 19th, 2022.
Yeah.
This bug was reported as just a standard bug. It's just, hey, this is a bug because I can't get the real request file name. Nobody saw the connection and the problem of this as like a security issue. It was just an issue of you can't access like the whole thing there, and it's a little bit wrong.
Seems like
And
it just
yeah,
kind of got lost in the void, like
yeah, because
fell
they
through the
just
cracks, I guess.
basically say like request URI raw exist, and you'd be able to get the original out of that. You could derive it and do something work yourself. But yeah, like the fact it was known about in 2022, anybody kind of could have seen this sort of thing then, and it just kind of kept slipping through until somebody actually called out like, hey, there's a security issue with this. So yeah, it's a cool bug. It's a really nice find in terms of a like WAF bypass, especially because this is an extremely common sort of setup using ModSecurity, and it impacts like all the rules written over there. So really nice find. And I know some places still use V2. So I feel like this could have a bit of like sticking power, I guess. And worth keeping in mind.
Another
Of
thing to
course,
have in your tool bag of tricks when you're on engagements and stuff.
yeah, it's just one of those things. It's easy enough to test when you come across it, like, hey, does this work? And if it doesn't, whatever. If it's there, great. I mean, a lot of things also use V3, so it's not like you're or it's not like it's everywhere. Like people using the legacy is definitely more limited, but it's out there. So yeah, add it to your bag of tricks. I think it's a nice find.
Yeah, for sure. All right, so speaking of another thing that people use a lot, we also have some Docker issues that were posted by Snick. We have 2 posts from them. This first one details a vulnerability in runc, which is used by Docker along with Kubernetes and
I'm
other
just going to
container-based
stop
products.
you there and just say you have an interesting way of pronouncing that. I've always
What?
read it as sync, which is maybe a little bit wrong, but
Well, it's
seems like it would be correct.
SNYK, right? So,
Yeah, no, it is, but at the same time, I don't know. I don't know what
oh
their
yeah, it might be
pronunciation
sneak.
is.
Yeah,
I
the
don't know.
sneak.
I kind of thought that sync worked. I mean, I the 2 letters are wrong, but works with what their tooling is, which is the static analysis tooling, like syncs. But yeah, I don't know. You just had a very weird way, and I wanted to call that out. I'm not sure what
Yeah,
the official way is, though.
it's a bit of a weird name, so you just have to kind of run with it.
Yeah.
So they detail the vuln in runc, which is used by Docker, but also some other container-based products. And the issue here is based on executing a malicious image or building an image with a malicious Docker file or upstream image. As the primary point of exploitation here is the workdir directive, which those who have worked in Docker files have probably used before. It's used by Docker for things like the run directives and things executing at runtime via the command or entry point directives. The problem is that workdir directory is entered with changedir before privileged host file descriptors are closed. And so if you use the proc self file system and set a privileged file descriptor in this path for the workdir, it'll basically keep that privileged directory accessible and can be accessed by commands at runtime, which sort of opens a hole into the root file system. So yeah, it's just basically not considering like the proc file system there and how the privileged file descriptors can be abused.
I mean,
And
it is that, but it's also the order of things because they do close these file descriptors. It's not like they don't try to
they
do
do.
anything to prevent you from getting there. It's just because of when this happens, because it's happening during the kind of build stage, or you're capturing that reference during the build stage. You may use it later, but you capture it early. When they close it there, it's not going to close it for everyone. It's just closing your reference to it.
You're opening a handle before you would use it. Yeah. And that
Yeah.
kind of messes up the order of their checks. Yeah.
Yeah. So it's like, they try to do something, but having the access at this early stage lets you get around it. Really cool breakout, though. I mean, it is kind of like an old school style of breakout. It's the sort of breakout you'd see with like the CH root jails and all of that fun stuff where, you'd find one of these references like file descriptors somewhere outside of the sandbox and escape that way. It's a very classic thing, but cool to see here.
Yeah. And like I said, there is another Docker bug that was documented here. So in this other post, they detailed a Buildkit based container escape. And again, it involves a malicious Docker image. And this is due to a missing privilege check in a gRPC endpoint, which Buildkit uses for communication. In this case, that endpoint is one used when you specify a custom input format parser to replace Dockerfile's normal syntax, which I'll admit I didn't even really know was a feature it supported. I'm
Yeah,
not like a
when
Docker power user or anything, but Yeah, that's a pretty wild feature to support in my view, but
Yeah, when I was covering this on the prep stream, I'm like, I had no idea you could do this. Like I went and looked up what this was and how it worked and stuff. And yeah, basically it seems like the expectation is that you give this to another image and that image will send the intermediate representation of the config to or back over to Docker through the gRPC endpoints.
yeah.
But yeah, it's had no idea about this either. Just like, what is this?
It's kind of a weird feature. I'd be curious on what the rationality is for supporting it, but nonetheless, it exists. And as you said, that parser is a Docker image. It has access to a gRPC server with a bunch of endpoints for creating and submitting the IR for Docker to use. The container.start endpoint in particular can execute build time ephemeral containers, but it doesn't check the request security mode against the Buildkit configuration. And so by just passing a start request with an elevated security mode, they can launch a privileged container with full Linux capabilities and escape outside of the context of the original container that's being launched from. So yeah, I mean, it's quite an interesting bypass. Again, like it's in a feature that I didn't even really know existed, and I suspect a fair amount of Docker users don't know exists, and that's a great place to look for bugs whenever you're trying
Yeah,
to look for stuff.
yeah, that was kind of my thoughts with this too. Is this is just one of the things that's very straightforward bug. The gRPC server is generally being used by privileged areas that are, starting the containers, as container.start implies. Like it's doing these things that you would expect to be privileged actions. And so, just kind of digging around, you find like, oh, this syntax thing, this lets you start another container that gets to communicate with the RPC server all of a sudden. That's maybe less trusted. It could be a malicious or it could be user controlled because this syntax entry just needs to be in kind of anywhere in the chain of images being used. It doesn't have to be like something your image specifically does. It could just be in the chain of some box you use that suddenly does this check and suddenly gets this gRPC or gets access to this. I believe it is generally considered a privileged API. I may be wrong about that, but like I believe making the gRPC calls is generally a bit more privileged.
I would
So
imagine so. Yeah.
yeah. So I mean, getting access to that, it's a really deep and weird attack surface that tends to be ripe for bugs. So cool find. I mean, I don't know how many times you'll run into this exactly on a random bug bounty, but this idea of just looking fairly deep in there for that unexpected functionality is definitely worth exploring when you're looking for bugs, at least if you're doing that sort of manual analysis.
All right, so getting into our next topic, we have a chain of two vulnerabilities used to get Preauth RCE and Jumpserver, which is an open source privileged access management system. And again, we have a bit of a crypto aspect to this topic, and I'll let Z jump into it.
Yeah, and this one's great. It ultimately comes down to just the fact that two different systems use the same random number generator in competing ways, I guess. There are two components that matter here. So for our purposes, like Jumpserver is just a very privileged thing. Like you'll see a Jumpserver used in the context of like you want to protect SSH access to a box, so you would only access like certain internal like production boxes through a Jumpserver like this. That way, it's the privilege access. So like this can have a pretty deep impact on a corporate environment, being able to basically bypass a Jumpserver. Well, I mean, you're getting RC on the server, so but anyway, as for the bug, two components. One is password reset. This makes pretty clear sense. During the password reset, you're going to have a reset code generated for you. They use the standard random number generator to generate this code. You can make an argument about the security on that because the default random number generator here is not considered cryptographically secure. I'm just double checking if they call this out here. Okay,
What are
I
you looking
might
for,
be
sir?
I was doing a search for MT rand because I thought this one referenced it,
Oh, they,
but
they spell it out,
oh,
Mercant Twister.
mercy,
They, yeah.
right? Because PHP calls it MT_rand, but anyway, so yeah, they're using the Mercant Twister as the algorithm here. Yeah, PHP does the MT rand. That's what I was searching for, but this is in Python. Either way, they're not using a cryptographically secure crypto there. You can make arguments about like where you need to use the cryptographically secure. And this is a good place to do it because like password reset authentication definitely matters there.
Pretty sensitive area.
It is, although trying to leak the MT or the Mersing Twister's seed, kind of the internal value there, so you can leak all of the numbers that are going to come next, is not going to be trivial on something just like a password reset code, because you would need many of them. You can collect them with gaps. I think the tooling that exists today can kind of figure things out with gaps, but you need a lot of requests. But generally speaking, that is the issue with cryptographic or not cryptographically secure algorithms, is you can leak this seed if you get enough of the random numbers that were generated through it. I'm not sure if they did any hashing over it that would also obscure the numbers and stripping bits that make it more difficult, but there are things like that which make those sorts of things, like while it is a legitimate attack, a lot more difficult to pull off. However,
it's not practical in a lot of cases, but
yeah,
this is not one of those cases.
yeah, it's not practical in a lot of cases, but gets called out in a lot of cases because like it is a legitimate concern. But in this case, leaking the seed is so much easier because they also have a captcha that they use. And the way the captcha works is to generate the image, they would have somebody send in just browsing through here to make sure. Yeah, so right here in the captcha image function, they would take in, the standard request, a key, and the scale to generate the image at. Fair enough. So what it would then do, though, is that the key that is used as the key for the image, so like whatever captcha image they're showing, and this is just so like, every time they generate the captcha image, it's not something new. They can show you kind of the same image and they just need to store or know what key they were using. But are kind of, it's being treated like an identifier for the specific captcha you were showing, basically. But what they do is they go down here and take random.seed and give it the key. They give it the key that was provided by whoever was requesting the captcha image. Actually, I'm saying that, but I'm not sure if the key comes from the user or not, or
So
if
what
it's
it
just
is
fixed.
the key is provided to them through this refresh endpoint. So it says returning the key containing 32-byte hexadecimal string hex key. So they like keep that internal mapping, but they give you the key that is ultimately used to seed the RNG.
Okay. Yeah, my bad there. I couldn't remember where key actually came from. But yeah, so they disclose the key to you in this case, not attacker controlled. It's just simply that they disclose what key they just, or what seed they just use on the random generator. So you can go ahead, open up your own Python, seed random the same way, and be able to determine fairly consistently what the password reset code is. That's then used basically. Or at least it will give you the ability to do that within reasonable error. If there are other requests coming in using their RNG or something, you can have some things mess with that a little bit.
Yeah, I think at one point they state that they had to do like a gap of 980 bytes before like doing the brute forcing or whatever. Like they talk a little bit about the specifics of that,
Yeah,
but it's still reasonable and practical.
yeah, like it's they've destroyed their randomness by doing this. Is ultimately what it comes down to, and you can reproduce this on your own machine and get the value for the reset code without actually receiving the reset code. So really fun kind of crypto issue there. It's just a way that, crypto can be broken, not because you did some really crazy math, not because they just forgot to replace the test signing keys, but because they seeded the crypto. And in fact, like whatever code seeds RNG, it's always somewhere to kind of take at least a look at and make sure they're using an appropriately strong key. And in this case, like the fact they're disclosing the key kind of matters. But yeah, the seeding is always a challenge because there have been numerous bugs in the past that have all come down to just being able to predict that seed. Like, seeding by time used to be a common thing. So you are very able to take advantage of that if you just know, like, hey, what time did the server start at or something?
Yeah, you
Obviously, you don't see
calculate the
that
drift and you're
anymore.
good to go. But yeah.
Yeah, but like that was actually PHP's old session ID generator used to be vulnerable to that sort of attack because it would generate or it would seed based off of time the PHP engine started up, and I believe that was used for And this was like in 2009, quite a long time ago. But yeah, that was used for like a Facebook account takeover, well, session hijack, I guess. But um, like that sort of bug is around because people just don't really understand the nuances of random number generators. So,
Yeah, I mean,
again,
they're
thing to
fairly
keep in mind.
obscure, right, by design. So that that obfuscation makes it harder to use properly too.
Yeah, and one thing here is like it makes sense that the capture image is doing this and needing to reproduce and kind of start from the key and then reproduce that same image again. Like it's not a crazy thing for it to do.
It's basically trying to be too clever. It's trying to reuse values, which you can kind of respect, but in this case, it was a big mistake.
Disclosing it to the user is the mistake. If it were to maybe hash the key,
Yeah, if you had like a irreversible hash or something, that would make it more reasonable. Yeah.
yeah, like you could possibly brute force the digits down on that though, and like maybe get something with it. Like brute force the hash, so you'd want to include a secret there or something. Like if you had something like that, and then just your cache was based off of that key, there's maybe some other ways you could go about this, but like in principle, using the seed to be able to reproduce a random event or like what your random event did, like it kind of makes sense. And it happens relatively commonly, not always in a way that you're going to be able to exploit, but it's not an uncommon pattern to see, is what I'm saying. And then from there, they were able to take this to code execution because they had a post authenticated RC, which the Jumpserver supports setting up playbook scripts that would just automate a bunch of operations across numerous servers. And useful feature, but in the API, it had logic that allowed a pretty classic directory traversal. It does use the path.join. However, with path.join, the problem in how it's using it is that if you want the kind of gotchas with it actually in general on with Python, there's some other languages that operate similarly, but if one of the parts that you want to join is actually an absolute path, so it starts with a slash, it will basically just ignore everything that came before it and start joining onto that one. So you can kind of hijack if they're trying to have a prefix on it. You can kind of hijack the prefix and just join your absolute path and get something out of that. And get it to access the wrong file. So that included modifying writing and deletion of files. So with that traversal, they could do all of that. And so
It's a bit unfortunate because in a lot of cases, like when you're trying to prevent against path traversal, because a lot of the time when path traversal happens, it's when you're trying to build the path yourself and you're trying to do like string concatenation. And generally, the recommendation is use an API that's specifically for joining file paths. But in this case, that
well,
doesn't save you.
the
So
recommendation is generate your file path, like resolve it down to the absolute path to whatever you've created and check the
yeah,
prefix then.
but
That
generally what
is
will do that is like an API like path join. Like in Golang or something, that is what you would do. But in Python, like you said, there's a gotcha there and that kind of bites you
but you're
if you're
missing the one
depending on it.
step. With Golang, yeah, you would use the path join. Actually, I believe this vulnerability with join existed on Golang. I don't think it still does, but I think it did exist. I remember us talking about a similar bug with Golang quite a while back. But the difference is you do that, and then once you get the absolute path, so not only would you join the path, you would then like stat the file or something to get, or you would, well, usually you have an API then to also resolve it down to the full path. You would then do that and then check the prefix to make sure it still matches. You wouldn't assume that none of your input had any traversals.
Yeah, sorry. Yeah, you're right. I
So,
was neglecting that step when I was talking about it. But
like, had they checked the prefix here, this wouldn't have happened because they destroyed the prefix.
that's true.
Even without resolving it, like, they still just lack that check. So, as much as that is a gotcha with like a lot of the join options, actually with Golang, at least the latest versions 1.20, 1.21, they don't do this behavior. I do feel like we talked about in the past where you did have this same behavior. Nonetheless, at the very least here with Python, this is a gotcha. And it is something to keep in mind. But ideally, if you're checking for path traversal, you should resolve it down to its absolute path and check the prefix. Make sure you're not dealing with a symlink or something like that in there too. It's another thing to consider. You can't really do that with a remote server, but at least on local stuff, symlinks are another kind of pain point for a lot of systems, and we've talked about a lot of those bugs. But yeah, standard process, you really should at least be checking the prefix. They don't do that here at all. They just join it and assume it's going to be good. So like this would be vulnerable to path traversal. I guess path.join isn't going to join your // so maybe not quite, but still, I would just say it's lacking that extra step.
Yeah, and I mean, this is sort of your classic case, right? Like, we see this a lot where once you're able to break through and get an authenticated session, the API endpoints are pretty soft. They don't really do a lot of checking. It's that hard shell, soft inside, like egg sort of design. So, like, the RCE didn't surprise me at all. Like, once you're authenticated and having this sort of path traversal, we see it all the time in topics that we cover. But that first issue with the crypto, the RNG seed being leaked is a pretty cool thing that you don't really see every day. So
Yeah, it's a good bug, and like you're saying, it is kind of a soft inside, especially on a target like this, where most of the people that are actually going to be able to. Actually, I guess I don't know what the user levels are with this, because I mean, if it is the users just being able to SSH somewhere, like use the jump box to access something else, I guess you would have a lot of people accessing it. But like the people that are able to set up these playbook scripts, I feel like they're going to have access to like run code because they're literally creating code to run on servers. So like they're very privileged individuals already. So the fact that it's not like taking a lot of security there and kind of trusting those users, yeah, as you said,
it makes
isn't that
sense.
unexpected?
Yeah. Now, sorry if you were about to jump into this, but there was also a bonus issue in the post. They posted it in the bottom, and it's basically just the fact that the admin, like the default admin account, would be created with this email of admin@mycompany.com. It says my company, but I assume that's a typo. But yeah, they just state potentially it could be an attacker controlled domain, although we checked, like, talked a little bit about this for the show, and mycompany.com is not a domain that you can register. So realistically, like, this isn't really going to be a reasonable attack. But it's something to keep in mind that, whenever you're creating a default accounts, to keep in mind that the email shouldn't be something that can be registered by an attacker, because in the cases that it can be, like, yeah, they could have taken over the default admin account and done some damage here, if that was possible, which it isn't. But
Yeah,
it's
and
worth noting.
I guess I will say mycompany.com can be registered. My company though, that can be. So
If it is a
you
typo in the
know,
product, then yeah, it would be more significant.
yeah, I
Uh,
do. I imagine you're right that it is just a typo and it was admin@mycompany.com. Yeah,
I say it's
it's.
more likely to be in the blog post than in the product, but it's hard to say for sure.
I feel like a typo there would have been caught a lot easier because, developers would have been using that default email probably to test things and such. So they would be much quicker to catch my company than just a typo in the post. So I would imagine it's the post, but yeah, we
Yeah.
don't really know either way, I guess.
Yeah, but a cool RCE chain, and like I said, it's nice to see crypto issues pop up when they do, because we don't cover them a lot.
Yeah, and this is one of those crypto issues you can find yourself. It's nothing crazy. It's no weird
You don't
math
need
or
to be a
anything.
math expert. Yeah.
Yeah, it's just understand that seeds and the seed to a random number generator is very important, that it's remaining secret.
So our last topic is a blog post by Abhi Sharma on a multi-factor authentication bypass and Extendly that got them $500. So I'll let Z get into this one, and then we'll wrap up the show.
Yeah, and this one is a little bit so it's really simple to explain how it works. Basically, they had the endpoint there, the API/integrations endpoint, and then personal access tokens. You make a request out to this, it's post request. You can label, whatever you want. But post request this and you get an API token back for your own account. And part of that process, the normal process would be that when you make that request, you will then have to respond to an MFA challenge. So you would have to, validate your code, whatever. They make you go through MFA, which is a smart move. Another good move would just be enter your password before they're going to generate you personal access token. But MFA is there too as a fair move to ensure that you're actually allowing the authorized user to like do this. Um, The problem is if you were to say just spam that endpoint with many requests all at once, while many of them will get blocked by needing the MFA, some of them will actually go through, and they have the image here where there's just this one request kind of in the middle that is a 200 OK request that generated a personal access token without the MFA being done just because they were spamming it a bunch. And we were kind of talking a little bit before the show, like, how does this happen? And quite frankly, I don't know.
Yeah, I was
My
trying to rationalize it and like try to assume why this might be happening, and I came up short. Like I just it seems weird. It was the way they discovered it is like awesome, and they might not have all the insights into why this happens. It just kind of matters that it happens. But yeah, it is hard to rationalize even as far as races go.
Yeah, well, it's not your classic like ray limit bypass where you just have that limit on something. It's not necessarily ray, but that limit bypass thing. But it is in line, I think, with the research that James Kettle was doing. And put out this summer, Support Swiggers smashing the state machine, which looks at these sort of, a bit harder to explain race conditions. And from that, like, what's potentially going on here is that there's just like a transitive state going on that, let's just imagine a scenario here where when somebody needs to do the MFA challenge, it sets a flag on their account and like changes a value somewhere. And when it's in between that, like maybe it's changed the value. It said, here's what their MFA token's going to be, but hasn't flipped the flag yet to say they need to do the MFA challenge. So this would, if they're updating this in the database and they're not doing this as a single like atomic transaction, which would be kind of the proper way to do this, either as a transaction, commit it and all of that, or whatever. But you'd have that state where, it has the MFA code in, but seems like it's done in a sense because the other flag isn't set. Again, this is just one way an MFA could be implemented, and I have no idea if they're doing it here, but where you kind of have that transitive state where they've partially filled out the information, and in that case, it maybe looks like it's actually completed the MFA challenge. And then, there's a very small window before they actually flip the flag that enforces the MFA challenge where this request is able to slip through. That could be going on. Like, it basically just seems like there's probably some transitory state where they're updating values. And in the middle of that, at one point, you're able to kind of get a request through that looks legitimate because the data has been modified in kind of a weird way because it's partially complete and not entirely complete. And that's the sort of state machine that is talked about in the Smashing the State Machine post, where it's like these sort of race conditions that are taking advantage of the transition period between different states. And as the state machine, as they'd call it, is getting updated. So that would be my guess on how this one works. I don't know for sure if that's how this one works, but it does feel like the
It
sort
does
of
make
thing
sense.
that's
It's better than anything I could think of as to why this happens. So
yeah, it feels like it could fit. Maybe not exactly as I described it because that is a slightly weird MFA setup, but you know, there are cases like that could happen. So there's also just the fact that being in the MFA state is kind of one of those weird third states that can sometimes create problems in general because you're authenticated, but you're not yet authorized. And being in that state is just kind of weird in some systems and has these sort of side effects. It's a great find though, because I think a lot of people probably wouldn't even think of just trying to brute force, or not really brute force, but spam that endpoint to see what happens. And in this case, they got through with that. It's a great find.
yeah, for sure. It's in these kind of complex areas, you can just like bombard it and see what happens and observe. Like that is a viable strategy that you might not. It's not like as elegant as a full write up might be, where you're going in and root causing and trying to follow the complete flow or whatever, but it works. So it's a good reminder of just thorough testing can uncover these kind of crazy issues that are really hard to spot in the code itself.
Yeah.
All right.
Although I guess they might have been they were just trying to bypass the max of 10 API key limits and got this MFA bypass. So in
Yeah,
fairness,
they
they didn't
noted
think
that
of
they
trying
found
it
it kind
here.
of incidentally, but
Yeah.
again, like I said, like what matters is that they found it and they were able to find it through this testing, right? Like
Yeah.
that's the cool thing, is you might not even be necessarily looking for an issue that you can uncover just by observing what happens. All right, so we do have a shout out before we wrap up the episode, which is HTTP downgrade attacks with SmuggleFuzz. Z, you spotted this one, so I'll let you comment on it quickly, and then we'll wrap it up.
Yeah, SmuggleFuzz seemed kind of cool. It's looking for kind of the downgrade situation. So we've talked about, and there's research about kind of the HTTP2 to clear text, or was it to clear text? Whatever. Like downgrade HTTP2 request smuggling by when it gets downgraded by like the front end server. So this is kind of fuzzing for some of those sorts of issues, seeing if you can get like the line feed injected coming as an example, coming from the HTTP2 headers, just has a fuzzer there trying to see if you can detect or get the downgrade. Mostly, I think, on the detect side. Either way, it seemed kind of interesting at glance. I have not used it. I have not dug super deep into this, but new tool. Kind of want to call it out as, or actually, is it a new tool? This thing says 2021. I'm not sure if that's the date it was posted. No, okay. This article published
No,
was
they were talking
2024.
about the article. Yeah.
Yeah, fair enough. I just saw that and got a little bit worried. Either way, it sounded cool. I saw this on Reddit. I'm like, hey, check this out if you're interested in it. I haven't used it. I haven't looked deeply into how it works and stuff. It just looks cool. So there it is.
So that's all the topics that we have for this episode. So as always, thanks goes out to everyone who tuned in. You can join our community by joining the Discord and Twitter. Links for those are down in the description. And with that said, we'll see you in the next one.